Hello guys, myself Angita. So today we shall see another problem. Count negative numbers in a sorted matrix. So given a m cross n matrix which is sorted in non-increasing order, both row-wise and column-wise, return the number of negative numbers in the matrix. So the question says they're given a matrix and the elements are in the matrix are non-decreasing, increasing order. That means it's in the descending order with respect to both row and column-wise. How? So if you see this example, if you move row wise means this, okay. Column wise means left to right you move. So all the elements you could see they're in a descending order. Similarly, if you move from row wise, that means top to bottom, again it's a descending order. 4, 3, 1 minus 1, 3, 2, 1 minus 1. So this is what they're given. And you have to return the number of negative numbers in the matrix. So which are all negative numbers? 1, 2, 3, 4, 5, 6, 7, 8. 8 are the number of negative numbers in the matrix, and we have to return the count. So what is the usual approach you could do? You can just run two loops, for loop. One is row wise, another is column wise, another loop, and check whether the element is less than 0. If it is less than 0, let's keep a variable count, initialize it to 0 and increment the count. This is the normal way. But do we need to do that? No, not really, because they have given the hint here. The elements in the matrix are in the non-decreasing order, both row and column wise. That means what we'll do is we shall keep a pointer in the first row, last column. Okay, first row, last column. So let's keep a pointer here. So when you keep a pointer here, so we are moving like this, top to bottom, right to left. So we'll give a condition. So while row, whatever you have, that should be lesser than or equal to or lesser than m. M is something but the 4 and n equal to also 4. So m is row size, n is column size. So row should be less than 4. 0, 1, 2, 3 is the index you have here. Here also 0, 1, 2, 3. So with this, row should be less than m. And what about column? Since we are moving from light to ref, so column should be greater or equal to 0. So this is the condition. Until this condition satisfies, first check in the first row, last column. Okay, initialize row equal to 0, column equal to n minus 1. So row will be 0, column equal to n minus 1. So why are we doing this? Because you'll get to know why are we starting from the last column but first row. So you check whether the given number at this position is negative or not. Is it less than 0? Yes, it is. If this is less than 0, that means one thing can confirm the elements in this column will all be negative only. Why? Because they have told it's the elements in the matrix are in the non-increasing order with respect to both row and column wise. So row wise, if you go move down, row wise means you're moving down. So if here itself is negative, the further elements in this next row will be negative only. The same column. If you move to next row, negative, 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 smaller, smaller, smaller row it goes because it's in a decreasing order. Similarly, column wise also it's in a decreasing order. So if you find a negative here, okay, if you find a positive here, that means then yeah, till here only you have the negative elements. So one thing we can confirm is once you find an element a negative, in that particular column, all the rows you find, right, minus that will be in the decreasing order and that will always be negative. So how can you get the count? Count will be nothing but the row minus the position at which the index is pointing to, that is row. So m minus r is nothing but 4 you get. So count will be incremented to 4. Else, what if the elements is greater than 0? So that means, okay, now once you do this, column minus minus you do. Why column minus minus? We have to move to this column now and check whether the element at this position is negative or not. Is it negative? No. If this is not negative, that means yes. In this row, that's all. In the first row, when this element is negative and the due to which the in all the rows in this column will be the negative element, so you do m minus r. So here you could see element is greater than 0, that means yes, in this row it is done. Now you can move to next row. So if it is greater than 0, move to next row. So row plus plus. Now again check, row plus plus means you will move here, same column but next row. Why are we not moving to this column? Because this is already calculated m minus r. As I said, row wise also is in decreasing order, column wise also is in decreasing order. So if you see from this row to this row, if you move, you have here it is decreasing order means here if it is negative, next all the elements will be negative only because it's moving in a decreasing order. Similarly, in the this is in the column wise and row wise also same thing happens. So that's why I have given m minus r. You need not to move to next further elements in this column with respect to each row. So you move to this column now. You are in this column. Check whether the element is negative at this position. No. So that means again, yeah, this row is done. These two rows are done. Move to next column again. Next row, this same column. So here, if the element is negative less than 0, yes, that means all the elements down to this will be negative only. It's in decreasing order, no? That's why. So if this is negative, next all the elements will be in the negative only. So m minus r, m is 4, minus r is nothing but pointing to 2. Yes, that is 2. So count will become 6 now. These two, minus 1, minus 2. So count is 6 now. Got it? So once done, again do column minus minus. Column will point here. Is this negative? No. Move to next row. So when you are moving to next row, is it negative? Yes, it is. So again do m minus r. So that is nothing but 4 minus 3, that will be 1. So it will increment to 7. Now column minus minus, again it is negative. 4 minus 3, again it is. So that will give you 1. So it will become 8 total. So you found the count as 8. So basically what are we doing here is, if I need to tell again briefly, the intention behind starting from the last column but the first row is this purpose only. As they have told, if you are moving in a decreasing order row wise and column wise, you could see if here it is negative, the next row, the same column will be negative, 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 and that will be in decreasing order only. So that is why. So here in this way also, if you see here -1, next all the elements further to this, next to this in the right side will be negative only. That will be lesser than -1. So that is why we are not running the loop. We are just checking here. If this is negative, entire in this column, entire elements will be negative. Okay, so move here. If you once find this positive, move to next row. Okay, you will move column minus minus when you find the negative elements. If you found the positive element, you move to next row. Again, check if it is negative. No, move to next row because no more elements on this before to this can be negative because it's in a decreasing order. You can't have here a greater, smaller element than this. You move to again next row. Here again you check -1. That means yes, this entire column, this same column will have the negative element. So m minus 2 will be 2 here. Again in this move here, it is positive. So go down and this down. You calculate like this. So this is the logic. Quickly we shall implement this. And let's say n. So we'll take one of the rows dot size. Next, what we have to do? So we'll keep a row, initialize it to 0th row, and let's say column, initialize it to n minus 1, last column. So until the row should be greater than or not less than m, and column should be greater than equal to 0. Check if grid of row and column. If it is less than 0, then what should be done? Count, I'll initialize it count plus equals to m minus row. Okay, then increment the column. Else we have to increment the row. That's also return the count in the end. Yeah. And for Java, same logic applies. So we will submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.